Right. So the question 307 for apple redistribution to box. You are given a apple of size n. One second. You are given an array of size and an array of size, capacity of size m. There are n packs where ith pack contains apple I apples. There are m boxes as well, and the ith boxes has a capacity I apples. Return the minimum number of boxes you need to select and distribute these n packs of apples. So example apple 132 and capacity 43152. Output we will use boxes with capacities 4 and 5. And it is possible to distribute. One second. It's possible to distribute. To distribute capacity, it is possible to distribute the apples either total greater than or equal to total number of apple less. Okay. I equal to n apples length. 1 equal to m is equal to capacity dot length m. Apple redistribution into boxes. You are given an array of apple size m of n and array of capital size. Right. Easy question. Question number capacity of size m into n. Right. To use like greedy approach में जाएगा. After we have to do the sorting. Like if we use greedy approach and sorting, so we need to pack all apples into the minimum number of boxes, right? So since apples can be spread across boxes, this becomes a simple optimization problem, right? Of strategy used to largest boxes first. By prioritizing larger capacities, we minimize the total number of boxes needed, right? Like, right. If like capacity is like 5, 4, 3, 2, and 1, right? Why this is work, like if we need to pack n apples total, so using bigger boxer means we reach that we reach at the target of your selection. So how do we like next steps? Firstly, we used to calculate total apple needed, right? And we do then we do sort boxes by capacity in descending order, right? Then we apply greedy approach, select boxes until all apples are packed, right? And then do start with the largest box and subtract its capacity from remaining apples and continue until there are no apples left. And finally, count the boxes used, right? And after that, time complexity is we go n plus m log m, and space complexity is we go m, right? So let's do a code. I understand what he says. If I do counting short, right? So counting short is better than the linear complexity. But since the number of boxes and their capacity is small, so its performance maybe have no difference or even slightly worse than a standard short, especially when the frequency are sparse, right? So firstly, we do the code, right? So int sum is equal to arrays stream stream apple dot sum, right? And we'll write interval area. Then we have to do, you can see, so int fq, hold on, q equal to new int s int 51, right? Int f150. Then if the int high 0 ले लेंगे, low 51 ले लिया. If I int high to 0, low is equal to 51, right? And then we're creating a loop for int cap, right? And then fqc increment, and I is equal to math dot max I c, right? And low is equal to math dot min low c, and then we creating like low creating करते हैं int high maths here. Int high maths here and then low maths कर दिया, right? And like then we do a subtracting. We have to say that. So int is equal to 0, right? For int I is equal to high to low, and some 0 I increment, right? And for in if do I creating a loop, right? Then we do a while if you 0 and some if I creating this, I do sum greater than 0, then sum minus equal to I, right? And this increment and then do a return. So doing a return one thing, if I do return, it is not working. Is into C line 12. 1 second. Into C. Line was line 3rd. And it's an array. Upload some. Into C cap. Like if no, let's go copy the code. I think and then you have to delete this two, right? Two columns. So then you have to submit the code. Where it is running, right? And now to do GLG. The day. No problem. Count element less than or equal to gain a sorted array. Sorted. Or binary search से use नहीं होगा sorted है तो. Given a sorted array containing a distinct positive integer that has been rotated adds a non-pivot and the value x. Our task is to count the number of elements in that or less than or equal to x. Input here, output 235 less than topics we have, right? How I do this? ठीक है, तो if एक अगर n ले लूँ, मैं साइज स्टार्ट 0 कर देता हूँ, एंड n-1 कर देता हूँ, राइट, एंड देन वी डू बाइनरी सर्च for in mid में, right. int and count C में करता हूँ, चलो C को ट्राई करें, int and क्या अगर मैं कर सो काउंटलेस के पिवट नहीं आना चाहिए था, यार पिवट आना चाहिए, int वेक्टर int एरे तो ठीक है, find pivot, right, and array ठीक है, right, then int n is equal to dot size int start to 0, so and equal to n-1, and answer equal to 0. If the answer, then we do, right, then we apply a binary search. So firstly while start equal to end, right, and end mid is equal to start plus end divided by 2. If array mid equal to is 0, right, and start equal to mid plus 1, else is equal to mid minus 1, right, and then we do mid, right, and after that return answer, right. And then we do like so we do int count, int ले लिया, then int आगे रहते हैं, int x index and vector and array, right, So end index में कर देगा upper boundary, upper bound, and array dot begin plus L, and array dot begin plus R plus 1 X not int is equal to IDX plus L, right, and then return CNT, right, and then they do int जो count less equal vector है, right, जो हमने चेंज किया था. So int count less equal int x. So int pivot equal to find pivot, right, int answer is equal to 0 and n is equal to array odd size, and answer is equal to count 0 what this one have array count pivot and minus 1 array, right, return answer. Then we do return answer, right. Let's see, compile करके देखते हैं अगर होता है तो, right. गलत होगा. Let's see. So in collision I do some the error. So, right? So that's right.